So chirality simply means handiness. So to demonstrate chirality, let's use our right and left hands as examples. So let's take our right hand and place it next to a mirror. The reflection that's produced will be that of the left hand. And likewise, if we take our left hand and place it next to a mirror, the reflection that's produced will be that of the right hand. So we call our two hands chiral. In other words, they're mirror images of one another. They're non-superimposable. And that means no matter how much I try to rotate my right hand, I will not be able to produce my left hand. And likewise, no matter how much I try to rotate my left hand, I will not be able to produce my right hand. So in the same way that my right and left hands are chiral, chiral molecules also exist. So let's define what chirality is. Chirality is the ability of molecules or compounds to exist in two non-superimposable mirror image ways. So as an example, let's look at 3-methylhexane. So here we have our central carbon attached to 4 different groups. So we have the H group, the orange group, we have the green group or the ethyl group, the blue group is our propyl group, and we have the red group, our methyl group. And let's call this compound A. Now if I take compound A and place it next to a mirror image is produced within our mirror. So we get a reflection. And let's call this compound B. Now, no matter how I rotate the compound B, I will not be able to recreate the original compound A. And we call these two molecules chiral molecules. They're mirror images of one another. And another name for these two compounds are enantiomers. Enantiomers are compounds that have the same exact molecular formula, but they're mirror images of one another. So these two molecules, just like our hands, are non-superimposable. There's no way that I rotate this molecule and I'll be able to get back my compound A. Now, in this chiral molecule, this central carbon is known as a chiral carbon. A chiral carbon is simply a carbon that is attached to 4 completely different groups. So in this example, we have 4 different groups: our H group, the methyl group, the ethyl group, and the propyl group. So, not all molecules are chiral molecules. Some molecules are achiral. So let's see an example. So 3-methylpentane is the following molecule. We have the central carbon. It's attached to a methyl group, the red group, the H group, the orange group, and 2 identical ethyl groups, shown here with green spheres. So let's call this compound C. So if I take compound C and place it next to our mirror, I will produce our mirror image. And let's call it D. But if we rotate molecule D 180 degrees, we will get back our molecule C. This is because the central carbon is no longer a chiral carbon. And that's because for a carbon to be a chiral carbon, it has to be attached to 4 different groups. In this case, 2 of our groups are identical. They're the same. And so that means this central carbon is no longer a chiral carbon. And so this is a chiral carbon, achiral. And so this entire molecule is achiral. A mirror image does not exist. If I take the mirror